To help get ready for the upcoming test, we're going to go through a couple problems that kind of summarize what we've done in this unit. So we started with just solving equations. Okay, the very first day we started with solving one-step equations. So for example, x minus 7 equals 15. I'm going to add 7 to both sides to get that x by itself. So then x equals 22. Right? Remember, you can always check your work by plugging it back in. So if I plug in 22 for x, I end up with 22 minus 7 equals 15. 22 minus 7 is 15. 15 equals 15. So I'm good. All right, then we went into two-step equations. So now instead of just adding or subtracting something, I have two steps to do. So remember, you start farthest from your variable on that side. Okay, so on this side of my equation, the farthest is the 5. So I'm going to subtract 5 from both sides. So then 3x equals 7. Oops. Oh, maybe not. There we go. 3x equals 7. I'm going to divide by 3. So then x equals, and I cannot simplify 7 over 3, so I'm just going to leave it. All right, I can plug this back in to double check. 3 times 7 over 3 plus 5 should equal 12. All right, 3 times 7 is 21. 21 divided by 3 is 7. So 7 plus 5 equals 12. 12 equals 12, and I'm good. Then we started solving equations where variables were on both sides. Okay, now remember, you have different ways of solving these equations. You got different orders that you can go in. Right? Generally, I will move the variable to where I can prevent having negatives. So if I can move this negative 4x over here and keep everything positive, that's what I'm going to do. So I'm going to add the 4x to both sides. So I got 6x minus 11 equals 25. And now I'm back to a two-step equation like we just did. So I'm going to add 11. 6x equals 36, divide by 6, x equals 6. Just like before, double check by plugging it back in. So 2 times 6 minus 11 should be the same as negative 4 times 6 plus 25. Oh, there it all came at once. All right, 2 times 6 is 12. Negative 4 times 6 is negative 24. 12 minus 11 is 1. Negative 24 plus 25 is 1. So I'm good. Then we went into solving for specific variables. Okay, so now I won't necessarily have just one variable in my equation. I might have more, but I want to get one variable by itself. So in this case, I want to get p by itself. Alright, so I'm going to do the same thing, work farthest away and get closer. So I'm going to move my q. So 4p equals 12 minus q. And then I'm going to divide by 4. Alright, now technically I could leave my answer as p equals 12 minus q over 4. Alright, or when I go to divide by 4, dividing everything, right, splitting this up, I would get p equals 3 minus 1/4 q. Right? Either answer works. Right? In the future, we're going to have to start splitting it up, so it wouldn't be a bad thing to do now. But these are the exact same equations. We talked about percents and proportions. Right? So, and if I want to find the percent of a number, I've got to write a proportion. Alright, so 14% of 30. So I'm going to say x over 30 has to equal 14 over 100. Remember, your percent always goes over 100. To solve a proportion, cross multiply. Alright, so we would have 100x equals 14 times 30, which is 420. Divide by 100. Remember, when you divide by 100, you move your decimal place 2 to the left. So 14% of 30 is 4.2. Now I want to know what percent of 50 is 10. So if I'm looking for the percent, that means I'm going to have x over 100. And so I'm going to say 10 over 50 equals x over 100. Cross multiply. So then we get 50x equals, and 10 times 100 is 1,000. Divide by 50. 1,000 divided by 50 gives us 20. Alright, so 10 is 20% of 50. And the last one is just a proportion. We're going to solve by cross multiplying. 12 times 5 is 60. Has to equal 30 times x divided by 30. So x has to be 2. Solving inequalities. Very similar to equations, except the one thing that's different is if you are going to multiply or divide by a negative, you have to flip your sign. Other than that, the same rules apply as solving equations. So for the first one, we just did this one with the equation, but now it's x minus 7 is less than or equal to 15. So I'm going to add 7 to both sides. So x is less than or equal to 22. Graph this one on a number line. Put my number line, put 22 on there. I'm going to use a closed circle because it's or equal to. And I want all the x's that are less than 22. So I'm going to shade on the left side. Remember, if your variable is first, you can go where the arrow is pointing. So the less than is pointing to the left, so I can shade to the left. For the next one, we have 3x plus 5 is greater than 12. So I'm going to subtract 5 from both sides. So you get 3x is greater than 7. Divide by 3. X is greater than 7/3. Alright, go on the number line. Go to 7/3. Now, if you're just drawing your own number line, you could just put 7/3 on there. But if you're trying to fill in on one that's already drawn for you, think about where 7/3 is, alright? 7/3 will be 2 1/3, so I'm going to have to go between 2 and 3. Okay, I want all the x's that are greater than this, and so it's going to be an open circle, and I'm going to shade to the right. And this last one, alright, remember I said that we could solve these equations and inequalities that have variables on both sides multiple different ways. Okay, there's different orders that you can go in. So last time I moved the negative 4x over. This time I'm going to move the 2x just to change it up a little bit. So I'm going to subtract 2x from both sides. So you get negative 11 is less than negative 6x plus 25. Move my 25 away. So we get negative 36 is less than negative 6x. Divide by negative 6. If you multiply or divide by negative, you have to flip your sign. So right now it's a less than. I'm going to flip that to a greater than. Negative 36 divided by negative 6 is positive 6. Right? And I'm just going to rewrite this. I'm going to flip everything and put my x first. So instead of saying 6 is greater than x, I'm going to say x is less than 6. Go on my number line. I'm going to use open circle again. I want all the x's that are less than, so I'm going to go to the left.